In this session, we are going to continue from question number 26, Southwest Regional Mock 2022, Chemistry Paper 1 Advanced Level. If you haven't subscribed, consider doing so that you won't miss any of the future videos. Let's move right into the video. Question 26. The reaction methane plus chlorine giving us chloromethane plus HCl is an example of, so when we look at methane reacting with chlorine, it is a type of reaction where one hydrogen atom from methane has been substituted by chlorine, which means it is a substitution reaction. Now, what type of substitution reaction is it? This is a free radical substitution reaction, where what is reacting is a free radical of chlorine. After a cleavage homolytically, there are formation of radicals. Radicals are simply species with lone pairs of electrons. So this is the chlorine that is going to react as a free radical. So generally, halogenation of alkanes is free radical substitution, making our answer to be A. Question 27. Which of the following species is a Lewis base? What is a Lewis base? It is a species that has a lone pair of electrons to donate to a vacant orbital of another species, unlike a Lewis acid per se, which is a species with a vacant orbital. So when we look at these structures, we look at aluminium chloride, we look at boron trifluoride, we look at the OH minus, and we look at the hydrogen atom. If we draw out the dot and cross diagrams for this molecule, and this, we are going to realize that we have something like this. And in these structures, what we see here is aluminium having a vacant orbital. All the other three chlorine have octet structure, but aluminium does not have an octet structure, which means that it has a vacant orbital. Likewise, boron trifluoride, unlike hydroxide, which has lone pairs and oxygen, which can be donated to any vacant orbital in either of these components. So what acts as a Lewis base should be what has a lone pair to be donated and not what has a vacant orbital. So our answer is C, the OH minus. The proton is not a Lewis base, so a Lewis base is the OH minus. Question 28. Given the following enthalpy changes in kilojoules per mole, enthalpy of combustion of benzene, enthalpy of formation of water, enthalpy of formation of carbon dioxide. The standard enthalpy of formation of benzene is, so how do we go about solving this problem to get enthalpy of formation of benzene? Let's look at what we can do. So we have been given this equation for formation, but we also know that benzene can be formed from individual atoms of carbon and hydrogen. So we can normally rewrite an equation for formation of benzene, and we're going to have carbon plus hydrogen giving us benzene. Now we balance it and put the states. So enthalpy of formation is heat evolved or absorbed when 1 mole of a substance is formed from its constituent element. So these are the constituent elements here, and let's see how we can apply Hiss's law in this equation to calculate enthalpy of formation of benzene. Now from this, if we burn each of these in oxygen, we are going to have corresponding compound. When we burn carbon, we are going to have carbon dioxide. When we burn hydrogen, we are going to have water. And when we combust benzene, these are the same products we are going to have, carbon dioxide and water. So let's see, we balance the equation by putting 6 in front of carbon and 3 in front of water. And let's label the enthalpy changes. You can call this delta H1, delta H2, delta H3. So we realize that enthalpy of formation of carbon dioxide is the same as enthalpy of combustion of carbon. Enthalpy of formation of water is the same as enthalpy of combustion of hydrogen. So from this, we are going to apply Hiss's law. I'm going to take my loop in a clockwise direction, and if I do that, I say sum of roots equals sum of anti-root. This is enthalpy of formation. Sum of roots equals sum of anti-root. So if I go in a clockwise direction, I move towards this arrow, I move towards this arrow, I move against delta H2 and delta H1. Therefore, enthalpy of formation plus delta H3 to be equal to 6 delta H1 plus 3 delta H2, making formation subject of formula. Enthalpy of formation will be equal to 6 enthalpy 1 plus 3 enthalpy 2 minus enthalpy 3. And if you substitute the values, enthalpy of formation is going to be 6 into enthalpy of formation, that is delta H1, which is enthalpy of formation of carbon dioxide. We have seen here already that is the same as enthalpy of combustion of carbon. We have minus 393.5 plus 3 times delta H2. Delta H2 is enthalpy of formation of water or combustion of hydrogen. We have minus 285.9 minus delta H3 is combustion of benzene, and we have minus 3267.6. So if you punch that, enthalpy of formation is going to be plus 48.9 kilojoules per mole. That will be our final answer. We see from the options that our best answer is A. Question 29. An organic compound gives out white fumes with PCl5 and reacts with a mixture of sodium hydroxide and iodine to give triiodomethane. The compound could be, so we are based on two aspects here. We have white fumes with PCl5 and the formation of triiodomethane, where reacted with sodium hydroxide and iodine. Therefore, among all these compounds, which one will be able to give positive tests with PCl5? It should be the one that has an OH group, because PCl5 is used to test for OH group. So therefore, we are going to start looking at the one which has the OH group. A has OH group and C also has OH group. Now, between A and C, which one now can give triiodomethane when reacted with sodium hydroxide in iodine? So we see the conditions for alcohols to react and give positive iodoform. It should be methyl carbon, OH, with R and hydrogen. As far as we have this methyl group attached directly to the carbon atom carrying the OH group, it's going to give us a positive iodoform test, making ethanol to be our answer, because propanol does not have methyl carbon O directly, but this one does have. We open up ethanol, we have ethanol, CH3, COHH. So this is ethanol, methyl carbon OH, making C to be our correct answer. Question 30. The strongest oxidizing agent among the halogens is? So for the halogens, oxidizing power decreases down the group due to decrease in electrode potential values. So fluorine happens to be the most powerful oxidant, and oxidizing power decreases as we move down the halogens. So fluorine is the strongest oxidizing agent of the halogens, making our answer to be A. Question 31. For the reaction arrow going to give P, what is the order of the reaction with respect to arrow if the rate increases 9 times when the concentration of arrow is tripled? So the order of a reaction is simply the power to which concentration is raised. So the rate equation here is going to be K, which is the rate constant, R to a certain power, let's say M, where M stands for the order of the reaction with respect to R, and the value of M is not taken from the stoichiometric equation, but it is determined experimentally. We see that the rate increases 9 times when the concentration of R is tripled. What is now the order with respect to R? The order is 2. Likewise, when the concentration, let's say, of R doubles and the rate increases 4 times, the order is also 2. When the concentration doubles and the rate doubles, it is of first order. Now, what happens if the rate does not change even though concentration doubles? It is now said to be 0 order. It now tells us that the reaction is independent of the reactant. So, order of a reaction gives us the dependence of a reaction to a particular reactant. So, for this question, our correct answer is second order because rate increases 9 times as concentration of R triples. D is our correct answer. Question 32. A mixture that boils without changing composition is? So, a mixture of constant boiling point from Raoult's law is an azeotrope. An azeotrope is a solution that has a constant boiling point whose composition does not change on boiling. So, if we talk about non-changing composition, it means that the mixture has a constant boiling point and it is called an azeotropic mixture, making our answer to be C. Question 33. The lattice energy of rubidium chloride is minus 657 and its heat of solution is plus 9 kilojoules per mole. The hydration energy of rubidium chloride is, so the general formula for enthalpy of hydration, enthalpy of solution for a particular compound equals the enthalpy of hydration minus the lattice energy. So therefore means that enthalpy of hydration of rubidium is going to be enthalpy of solution plus lattice energy. If we substitute values, it means that enthalpy of hydration is going to be equal to enthalpy of solution, which is plus 9, plus the lattice energy, which is minus 657. And if we punch that, we're going to have minus 648 kilojoules per mole. That is our answer. And from the options, our correct answer is A. Question 34. Which of the following techniques would be most appropriate in identifying the position of hydrogen atoms in an organic compound? So for position of hydrogen atoms in a compound, the most suitable method that is going to be used is nuclear magnetic resonance. So nuclear magnetic resonance is used to determine and identify the placement of hydrogen atoms in the compound. For mass spectrometry, we talk about the determination of relative molecular mass of a particular compound. For X-ray diffraction, it tells us about the distance between layers of atoms in a crystal. For infrared spectroscopy, it is used to determine the presence of a functional group, if any, in a compound. So, for nuclear magnetic resonance, it is used to determine the immediate surrounding of the hydrogen atom and how hydrogen atoms are attached to the compound, making B to be our correct answer. Question 35. What is the oxidation state of sulfur in potassium persulfate? In potassium persulfate, this is really a tricky question. We look at this one. The persulfate is simply a dimer. Dimer composed of 2 identical sulfate ions. So our real compound is potassium sulfate. So the persulfate is simply a dimer. When getting the oxidation state of sulfur, we are going to concentrate on the pure compound. And let's say we don't know for sulfur, we call it X. Potassium forms potassium plus ion, and then sulfur is unknown, oxygen is 2 minus. Therefore, we're going to end up having 2 plus X plus minus 8 equal to 0, which is the overall charge. And then we have X minus 6 to be equal to 0, which means that X is equal to positive 6. So positive 6 will be the oxidation state of sulfur in this compound, making our option to be A. Question 36. Which of the following is an environmental effect of nitrogen? So A. It oxides cause acid rain. That's true. B. Its ammonium salts are used as fertilizers. C. Its atmospheric fixation to nourish the soil. D. Its nitride is used in the manufacture of rechargeable lithium batteries. In this question, we are interested on the positive impact of nitrogen rather than the negative impact. So we look at A. A is correct normally because nitrogen dioxide in the atmosphere reacts with water and oxygen to form nitric acid, of course. But its atmospheric fixation is to nourish the soil, which is the most important part of it. And even though A is correct, it is a negative impact, while C is a positive impact. So we focus on the positive impact, making our answer to be C. Question 37. What is the major product of the following reaction? We have propene reacting with hydrogen bromide in the presence of carbon tetrachloride. In this reaction, we talk about Markovnikov's rule. And Markovnikov's rule states that when an unsymmetrical reagent is added to an unsymmetrical alkene such as propene, the hydrogen atom in the reagent will attach itself to the unsaturated carbon with the highest number of hydrogen atoms. So therefore the hydrogen will attach itself to this carbon atom, while the bromide will attach itself to the other carbon atom, forming now a product CH3, CH3, where the bromide will be attached to the second carbon atom. And if we check, our correct answer is going to be B, according to Markovnikov's rule. Now for anti-Markovnikov's rule, the reverse is true. We are going to have compound A formed if it is anti-Markovnikov's rule. Feel free to pause the video and read the instructions before we continue. Question 38. For the reaction nitrogen and hydrogen giving us ammonia, the enthalpy change is negative, which means it is already an exothermic reaction. Option 1 says increasing the pressure increases the value of the equilibrium constant AP. Is that true? We look at the equation. They are all gases, so this is a homogeneous equilibrium where all the components in the system are in the same physical state. So in this reaction, when pressure is increased, equilibrium position will shift to a direction where there are fewer number of moles. So we expect the equilibrium position to shift to the right, since there are only 2 moles of ammonia, while on the left hand side we have 4 moles of the reactant. So as equilibrium shifts to the right, more ammonia is produced. So statement 1 is correct. 2. Liquefying the ammonia once formed increases the yield. That's also true because it will cause more ammonia to be formed, thereby favoring the forward reaction, which is also true. 3. The optimum conditions for the best yield are pressure of 200 atmosphere and a temperature of approximately 700 Kelvin. That's also a true statement. And the use of finely divided ion catalysts. These are the optimum conditions for the optimum yield. So we say that 3 is also correct. Therefore, all statements are correct, making our answer to be A. Question 39. Which conditions are required to give a good yield of ethanoic acid when ethanol is oxidized using potassium dichromate? What we have to know is potassium dichromate is always acidified so as the reaction, so as to increase the oxidation power. And heating under reflux is also a good point because the organic reaction is slow. 3 says distill the product as the oxidizing agent is added. The reaction is highly exothermic, so once the product is being formed, it has to be distilled immediately. Therefore, all the 3 options are correct, making our answer to be A. Question 40. Which of the following is an acylating agent? According to Friedrich-Crafts reactions, acylating agents are used on the benzene ring, where they form corresponding electrophiles, form different compounds. For acylating compounds, we have acid anhydride and acid chloride that can act as acylating compounds or acylating reagents. Esters do not act as acylating reagent. Therefore, 2 and 3 are acylating reagents during Friedrich-Crafts reaction. So our correct option is C. 41. What will happen when 1 cm cube of 0.01 molar HCl is added to a buffer solution of 0.1 molar carbonic acid and 0.04 molar sodium hydrogen carbonate. So they say the pH of the buffer solution will reduce. They say 2, the pH of the buffer solution will increase. By the way, what's a buffer solution? This is a solution which resists sharp changes in pH upon addition of small amount of acid or base. We see that this acid is in the smaller amount, 1 cm3. So we do not expect the pH to change, but it will remain fairly constant. So it will neither increase nor decrease, but will remain fairly constant. They say 3, the H ions from HCl will be picked up by the excess hydrogen carbonates supplied from sodium hydrogen carbonate. That is true. The hydrogen carbonates will pick the H plus ions, forming back our weak carbonic acid, keeping now the pH of the solution fairly constant. So we see that our option C or option 3 is the only correct option, marking our answer to be D. Question 43. Which of the following is true about carbonyl compounds? For carbonyl compounds, we have aldehydes or ketones. So they are telling us which of the following will be true for both the carbonyl compounds. They say both aldehydes and ketones react with Tollen's reagent to form a silver mirror. That's not true. Tollen's reagent is silver nitrate acidified. Only aldehydes will give a silver mirror with Tollen's reagent, and ketones will not, because there is a hydrogen atom directly attached to the carbonyl carbon. That's why aldehydes will give. 2. All aldehydes and ketones have antiseptic smell. That is a true statement. They all both have antiseptic smell. 3. The anion formed after the loss of the alpha hydrogen atom is resonance stabilized. Is this a true statement? So for the statement 3, after the loss of an alpha hydrogen from here, the anion form will have resonance stability, making option 3 to be correct as well as option 2, and our answer becomes C. Question 44. Compound A was prepared by oxidation of compound B with alkaline potassium permanganate. So we are saying that compound B was oxidized to give compound A using acidified potassium permanganate. Now compound A on reduction with lithium aluminum hydride gets converted back to compound B. So compound A is converted back to compound B when reacted with lithium aluminum hydride. When compound A is heated with compound B in the presence of sulfuric acid, it produces fruity smell of compound C. So compound A reacts with B, producing compound C with a fruity smell. So what could be compound A? For oxidation, let us realize that compound C with a fruity smell is an ester. Esters have a characteristic fruity smell. Now, they say compound B was oxidized to give compound A. If it is oxidation, it should be an alcohol that is oxidized to a carboxylic acid, because oxidation means addition of oxygen. So we should expect an alcohol to be oxidized to a carboxylic acid. So B should be an alcohol, while A is a carboxylic acid, because when you now reduce A back to B, it means that you are removing oxygen and adding hydrogen, because reduction is the removal of oxygen. So A should be a carboxylic acid, while B is an alcohol. Now, option 1 says A is an alcohol, which is already off. We have seen that B is oxidized to A, so A should be a carboxylic acid. 2. Compound B is a carboxylic acid. That is not true. Compound B should be an alcohol, because they say B is oxidized to A. So 2 is off. 3. Compound C is an ester. When an alcohol reacts with a carboxylic acid, an ester is formed. Therefore 3 is correct, making our answer to be D. Question 45. Consider the electrode systems. We have the first one for magnesium with the corresponding electropotential value. We have the second one for zinc with the corresponding electropotential value. They now say when the two electrodes are coupled to give a spontaneous reaction. 1. The cell potential for the couple is plus 1.6. To calculate cell EMF, it will be the large electrode potential value minus the smaller one. And if we check from these two electrode potential values, negative 0.7 is greater than negative 2.3. So we're going to have minus 0.76 minus 2.36. And if we punch that, we have our E cell to be positive 1.6 volt. So our statement 1 is correct. So for between these two half cells, the half cell with a higher electropotential value is said to be the cathode, while the one with the lower electropotential value is said to be the anode. So our first statement is correct. Second statement, the cell diagram for the process is... Now let's see how we can write the cell diagram. So between these two half cells, the zinc half cell will be our right hand side electrode, and the magnesium half cell will be our left hand side electrode. Now we see that these are metals, so we need not introduce again an inert electrode. An inert electrode can only come in when there are all ions. So if we want to write the cell diagram, we start with the anode, where we have magnesium solid separated from the ion by a slash, magnesium 2 plus ion aqueous, and this half cell is separated from the next half cell using a salt bridge to now have the second one, zinc 2 plus ion, and the zinc solid. So this is our cell diagram. So option 2 is also correct because the cell diagram matches with what we have. For 3, they say the couple forms an electrolytic cell, which is of course normal. 3 is also correct. Therefore 1, 2, 3 are correct, making option A to be the best answer. From question 46, you can read the instructions. Question 46, statement 1. The coordination number of sodium ion and chloride ion in sodium chloride crystal are each 6. That is true. In the crystal, we have a coordination number of 6 for sodium chloride. Statement 1 is correct. Now, for statement 2, sodium chloride lattice adopts a face-centered cubic unit cell. For the unit cell, we have something to demonstrate like this. So when we talk about faces, we are saying there will be coordination at the faces with different ions. So ions will be able to coordinate on the faces. It is phase because it is on this phase. So it is a true statement, but does not really give the reason why the coordination number should be 6. So it makes our option now to be B. Our correct answer is B. Question 47. The halogens show a change in physical state from gas in fluorine and chlorine through liquid in bromine to solid in iodine and astatine, which is a very true statement. Now, for the second one, they say down group 7 van der Waals forces increases in strength with increase in atomic number. That is a true statement, and that is the exact reason why the physical states are going to solid due to increase in van der Waals strength. So statement 2 does explain the first, making our answer to be A. 48. Ethanol and carbon disulfide forms a miscible liquid mixture that deviates positively from Raoult's law. Is that true? Ethanol and carbon disulfide. Ethanol has hydrogen bonding. Carbon disulfide has weaker van der Waals forces. So upon mixing, the hydrogen bonds in ethanol are going to be broken, thereby resulting to a mixture now with a lower boiling point and a higher vapor pressure. Statement 2. On mixing ethanol and carbon disulfide, strong hydrogen bonds in ethanol are broken by interaction with carbon disulfide molecules. That is a true statement, and that is why the boiling point decreases and vapor pressure increases, because it leads to the formation of weaker intermolecular forces. So this statement is true as well as this, and this one does explain the first. Our answer is A. 49. Ammonia coordinates with boron trifluoride to form this compound, and that is a true statement. This is called an adduct, where we have ammonia reacting with with boron trifluoride, and these lone pairs are going to be donated to this empty orbital, forming now the general compound. So where there is a dative bond here called a dative covalent bond, and that is why it is a coordinate bond. So statement 1 is correct. Statement 2, ammonia in its reaction with boron trifluoride behaves as an Arrhenius base. Ammonia behaves like a Lewis base, not like an Arrhenius base. So statement 2 is wrong and only 1 is correct. So we say that our answer is C. 50. Magnesium ion, aluminium ion, the oxide ion, and the nitride, they say are isoelectronic ions. Is it a true statement? Yeah, it's a true statement. Isoelectronic ions are those that have the same electrons, same number of electrons. So if we write the electronic configuration of magnesium ion, it will be 1s2, 2s2, 2p6, 3s0. So because 2 electrons have been lost from the s orbital, so it ends up being 1s, 2s2, 2p6. And for each of these, aluminium, oxygen, nitrogen, they will all have the same 10 electrons, because as nitrogen is having 7, it will gain 3 more to go to 10. Oxygen has 8 and will gain 2 more to go to 10. Aluminium has 13, losing 3, coming back to 10. So they have the same number of electrons. Now the second statement, the ionic radius of the ions increases in the order. So let's see, magnesium ion, we realize that magnesium, which is when it is neutral, has 12 protons and 12 electrons. So what do we expect to become of its radius when it loses 2 electrons? We realize that it now has 12 protons and 10 electrons. The force acting on it increases because 12 protons are pulling only 10 electrons. So as the force increases, it shrinks in size and reduces, hence the radius also reduces. For aluminium, the radius is also decreasing because we have we have 3 electrons that are lost. Therefore we have 13 protons pulling 10 electrons. So we expect that of aluminium to even be smaller than that of magnesium, because for magnesium you have 12 protons pulling 10 electrons, but for aluminium you have 13 protons pulling 10 electrons. So it automatically makes this particular one off. So this one is wrong, this one is correct, making our option to be C. So that's the end for this video. If you found it helpful, don't forget to give it a thumbs up, subscribe, comment, and share it with your friends. Thanks for watching.